Okay, we're in section 25. And again, the hope is that you've paid attention to the lecture. Um, so we're solving quadratic equations. And over the history of the course, what we did was we first used the technique called the zero product rule or factoring. And then we introduced the square root rule. And now we're introducing the perfect squares, all right, which relates to the square root rule. So the problems over here we go through, hopefully you understood what was said to you. And that is about the binomial perfect squares. They have a very nice pattern to it. And that's provide the coefficient on the square term is 1. All right, so we went through a bunch of examples over here. We also talked about numerical perfect squares. The deal about this, though, is what we're trying to do is we're trying to follow a method now. And I'm not going to say it's the best method, but it does work. It works nicely. This method does lead in general to what's known as a quadratic formula, and we'll get to that. But right now, what we're going to do is we're going to outline the method with the following problems, and we'll follow the instructions. Again, the method's clearly stated over here with an example for you. So let's go to the examples. I'm going to switch over to the whiteboard. And just give me a moment to do so. All right, we're on the whiteboard, and we're going to start doing the examples now. So the first example, it says solve by completing the square. So what I'm going to claim over here is if you just look back over the method and someone says, what method are you talking about? Well, the method we described in class. What we're going to do is we're going to rewrite the problem where we're going to isolate the constant on one side. And the way to do that in this particular problem is to subtract 2x from both sides. I'll write that down for you. And if you did that, what would you get? You would get x squared minus 2x. I'm going to leave a little space there, is equal to the number 3. Now what we're going to do is we're going to complete the square. And this is a tricky part. I realize that. So one thing I want to make sure you know that the coefficient over here should be 1. Now, if it's not 1, we have a little bit of a trouble. But I'm going to say right now, let's just concentrate if this is 1. If it's 1, what we're going to do is take half of this guy's number, this is the coefficient on the x term, which would be minus 1, and square it. Let me write that down for you. Half of the minus 2 and square it. Oh, they give me 1. And what we're going to do with that is we're going to add the 1 to both sides of the equation. By doing this, what we get is a perfect square on the left side, which is x minus 1 squared is equal to 3 plus 1, which is 4. Then we're going to use the square root method to solve the problem. What does it say? Well, we have something being squared. That's going to equal plus or minus the square root of 4. So what do you get up here? X equals 1 plus or minus. I'm adding 1 to both sides. Let me write that down for you. And what do you get? 1 plus or minus, well, what's square root of 4? 2. Now again, if you can do the arithmetic, please do the arithmetic. It's 1 plus 2, or it's 1 minus 2. And what does that give you? X is 3, or x is minus 1. All right. I want to go back to the old way of doing it. And it's important you realize that they're all going to lead to the same truth. All right. So let's go back to the old way. What's the old way? Well, it's called factoring. Or I say the zero product rule. That's how we first introduced it. How do you do that? Got to get a 0. Subtract 2x from both sides. Subtract 3 from both sides, and you get this. Then factor the problem. This is my favorite technique, by the way, if it works. 1 and 3 minus plus. Let's check it. X times x is x squared. That worked beautifully. Minus 3 plus 1 is minus 2. That worked beautifully, and we get minus 3. What's the answer over here? Well, 1 is the first factor becomes 0 when x is minus 1. Or 1 is the second factor becomes 0 when x is equal to 3. Now, you should realize we're getting the same exact answer. And why is that? Well, if we're speaking the truth, we should get the same answer, by the way. All right. The answers are also listed in the key for you. All right. That's problem number 1. How'd they ask me to do it? Completing the square. All right. That's the way I did it. But I also want to go back to the past to make sure we can do that. Of course, there's going to be a future, and that future is going to be the quadratic formula. And quadratic formula is going to lead to the same answer. My favorite technique, though, is the zero product rule or factoring if I can do it. I can't always do it though. Let's go to the next one. And again, I'm going to go through the procedure for you. This is number 2. The procedure should be relatively simple. Isolate the constant by adding 1 to both sides. And what would you get? Let's write this over here. You would get x squared plus 4x is equal to 1. You notice I left a space there. I'd like to have the coefficient here to be 1 because it makes it a lot easier for me to deal with it. And this is a 1. What do? Take half of the 4 and square it. Let me write that down for you. So if you took half the 4 and squared it, you would get 4. And what are we going to do with that? We're going to add 4 to both sides. And what do you get? Something pretty simple. You get a perfect square on the left, which is x plus 2 squared is equal to 5. Now use the square root rule. X plus 2 equals plus or minus the square root of 5. What am I going to do now? Subtract 2 from both sides. And what do you get? You get something pretty simple. You get x equals minus 2 plus or minus root 5. Now, what's interesting about the root 5, I can't write that down as anything else but the root 5. You could approximate it, but we're not interested. So what are the answers? I'll write down for you. Minus 2 plus root 5, or x equals minus 2 minus root 5. By the way, this is okay to write it this way over here, because I'll be honest with you, I can't do the arithmetic over here. All right, let's look at the k, see if we got that. I'm seeing this, and I'm seeing this over here. All right, I want to point out, if you try to do this by factoring, right? So if you try to do it by factoring or the zero product rule, you're going to come into trouble. For example, if I try this, it would be x and x. It's the only choice there, and the 1 and 1. When I say the only choice using finger numbers. And there's no way I can get a combination that would give me this 4 in the middle. So factoring would fail miserably. So this completed square does work. All right, it does work. And it allows me to get solutions that I couldn't get otherwise. All right, let's go to next, number 3. And again, looking at it, it says solve by completing a square. And I want to encourage you, complete the square. How do you do that? Isolate the constant by adding 39 to both sides. What would you get there? Well, not too bad. You get x squared plus 10x equals 39. Remember, we're taking half of the coefficient of the 10. This only works if the coefficient here is 1, and it is. Let's write this down. Half of 10 and square it. What would that give you? 25. What are we going to do now? We're going to add 25 to both sides of the equation. Don't be intimidated. What do you get here? On the left side, you get a perfect square, which is x plus 5 squared. On the right side, what do you get? Well, 39 and 25 is going to be 64. Square root rule, x plus 5 equals plus or minus the square root of 64. X is, I'm going to subtract 5 from both sides. And what do you get? You get minus 5 plus or minus the square root of 64. You should realize that the square root of 64 can be done, and that gives you 8. So my answer is going to be x equals minus 5 plus 8, or x equals minus 5 minus 8. I could certainly do that arithmetic. It would be 3, or x would be minus 13. Again, you do arithmetic if you can. Look at the k, and I'm seeing those answers. Now, I'm going to say I really would prefer to use not complete a square, but see if I can do the factoring technique. Let's see if we can do that, the zero product rule. Well, it's already set up. It's already set up to have a 0, but I don't have the product. I'm going to try, see what happens. You get x and x. What's the only choice from using finger numbers? X times x is x squared. 39, I'd say 3 and 13. Plus 13 minus 3. Let's see if that works. X times x is x squared. 13 minus 3 is 10x. That worked. And you do get minus 39. Well, pretty simple. What do you get over here? X equals 3 for the first factor. That's when it would become 0. Or the second factor becomes 0 at minus 13. Do we get the same answer? Of course we do. All right. Let's go to the next one. It's going to be number 4 now. I'm getting a little better at this. And I'm going to just work on it. What do you get? Take 13 from both sides. And what do you get there? You get x squared minus 8x equals 13. You notice I'm leaving a space there. I leave a space for a reason. I'm going to complete it. What does that mean? I'm going to complete the square. How do I do that? Well, I think I'm getting better. What are you going to do? Half of this number, that would be minus 4, and square it. What would you get? Plus 16. You're going to add 16 to both sides of the equation. And again, I'm getting more confident by trying. What do you get? X minus 4 squared equals, well, what's 13 and 16? That's going to be, let's see, 29, right? I'm sorry, did I make a mistake over here? I'm sorry, I did make a mistake, and I just noticed it. Let me go back and I'll show you where I made a mistake. I have to erase though. I made a mistake, and I'm going to keep erasing this. Oops, sorry about that. I made a mistake when I subtracted 13 from both sides. And I want to write down what I should have written down, minus 13. I'm sorry about that. And I was saying I was getting more confident with the problems, but I made a mistake. Confidence leads to mistakes sometimes. So don't be overly confident. All right, let's take a look at it. Again, what am I going to do? Half of that number, which is minus 4, and square it. And when you square 4, you get minus 4, you get 16. So we're going to add 16 to both sides. One thing nice about the notes, you'll have an answer key to look at. And let's not look at it until I get done. So it's going to be x minus 4 squared. And minus 13 plus 6 is 3. Square root rule, that would be x minus 4 equals plus or minus the square root of 3. I'm going to add 4 to both sides. I'll write that down for you. Now we'll just do it. Add 4 to both sides. What do you get? 4 plus or minus root 3, sorry. What does this mean? X equals 4 plus root 13. I keep saying it, it's 3. Or x equals 4 minus root 3. Now this didn't add much to the problem because I don't know the square root of 3. So I'd say this is a fine answer over here. Is it the same one we're getting in the key? It's the same one we're getting in the key. If you were to try this by factoring, let me point out why that's a problem. And the factoring is a zero product rule. It's already set equal to 0. Well, if I try this by factoring, and when I say that using finger numbers, what would you get? 13 and 1. And there's no way I'm going to get 8 out of that in the middle. So this would not work by factoring. And that's good news that we have a technique now. I'm able to solve that problem. All right, let's take a look at number 5. And again, my goal here is to follow the technique. And it's outlined in your notes if you can't remember. And that's fine to look back over the notes if you need to. So I need to isolate the constant. How would I do that? And I want to emphasize to you, the way I would do it is I would subtract 18x from both sides. And if you did that, what would you get? You'd get x squared minus 18x. I'm going to leave a space, equals minus 17. What am I going to do now? Well, that gives a coefficient of 1. So I'm going to take half of this guy. And they're pretty kind about that. For the most part, they've been giving us really simple numbers. What's half of this number? Minus 9. If you square minus 9, you get plus 81. So what do? You're going to add 81 to both sides. All right, let me keep going forward. And you get a perfect square on the left side, which is x minus 9 squared. Now, minus 17 and 81, let's see. That would be, let's see, 64, right? That's not so bad. Let's keep going. Square root rule. X minus 9 equals plus or minus the square root of 64. X equals 9. I'm adding 9 to both sides. Plus or minus. Well, what's square root of 64? It's 8. Let me write this down. X equals 9 plus 8. Or x equals 9 minus 8. What does that give you? X equals 17. Or x equals 1. Let's look at the K, see if we got the same answer. Got the same answer. I want to do this by factoring. All right, let me write that down for you. So x squared equals 18x minus 17. Remember, factoring is a zero product rule. So subtract 18x squared, 18x from both sides and add 17 to both sides. Again, this is my favorite technique if it works. X and X, 17 and 1 is my only choice. Got to be minus minus. Let's check it. X times X, X squared, minus 17 minus 1 is minus 18, and minus 1 times minus 17 is plus 17. Fairly simple problem. What do you get? X equals 1, or that's the first factor becomes 0, then X equals 17. Do we get the same answer? Of course we do. All right. So there's really, the point about this section over here is that, there's not many problems, but you've got to follow these things, these models that we've just given you, including the lectures that we presented to you with the examples in the lecture, and see if you can do it on your own. Problems follow. Make sure you do those problems. All right. After you do that, study this material, go do the web assign. Thank you.